What's up, guys? It's Mr. Brengle, and today we're going to look at part 2 of our graphing practice. So at this point, you should have already completed all of your original graphs. There are 4 of them. The first one was with pressure and volume and is a hyperbola. The second one is with position and time and is a parabola. The third one is with velocity and mass and should be a line. And then the fourth one is with time and velocity and should be a Groot graph. Okay. Now, the second part of this assignment is to take any of the nonlinear graphs. So that would be the hyperbola, graph 1, the parabola, graph 2, not graph 3 because it's already linear, but would include graph 4, which is the Groot graph. Okay, so we're going to take these nonlinear graphs and we are going to make them linear because it's a lot easier for us to work with the equation for a line, y equals mx plus b. That will help tell us things about the experiment. So we will have already talked about how to linearize things in class. So this hopefully will just be a bit of a review. But you'll remember that in order to linearize something, you have to look at the equation for the graph down here, okay? So the equation for a hyperbola is y equals 1 over x, right? So over here, this is our x-axis, and this is our y-axis, okay? Volume and pressure. Well, if we just graph, instead of x and y, if we then graph 1 over x, like in the equation, and y, just the way it was, then it will turn into a linear graph for us. So what I mean by that is down here, instead of graphing whatever was on the x-axis, I'm going to graph 1 divided by whatever was on the original x-axis. And then over here, we're going to leave the y-axis the same, what it already was, right? Because it didn't change in the equation. Y is still y, okay? 1 over x instead of x, which is why we're doing this. So I'll highlight these in some other color here. All right, so this means I have to change my title too. It's no longer volume, but it's 1 divided by volume. And that also applies to the units. It's 1 over meters cubed. Okay? By the way, the caret symbol there is what we use for exponents. So we now have 1 over volume, and we'll go ahead and leave pressure the same, and that's going to be in pascals. Okay. And so what you can do is you can just go ahead and copy the values from pressure, but for volume, we need to enter an equation. Okay. So to enter an equation, we're going to hit equals. And then all you're going to do, since we're going to do 1 divided by volume, we're just going to hit 1 divided by. And then all you have to do is click on this 0.1 over here. It's going to do 1 divided by A2, which is the cell. And then if we hit enter on that, click it, and then go to this little blue square in the bottom right corner, your mouse turns into a little crosshair thing. If you grab that and drag it down, it will put that equation in for all of these here. And you can see when I look up here, it's 1 over A2, which is this one. This is 1 over A3, which is the next one, 1 over A4. So that's just a quick way to populate those without having to put the equation in every single one of them. Okay, now let's look at what happens when we graph this data right here. So let me kind of pull this over to the side here. Okay, now I'll move my face cam. So notice that these all look very linear, and then there is a point that's way up here. So if you're having issues with your axes, remember, you can increase your vertical axis there. We could go to a max value of like 45, and then you can see that a little bit better. If you don't care, you can just leave it. But the big thing here is that we want to make sure that we check our title and get rid of the units because that's too busy. We don't need that there. So pressure versus 1 over volume is our title. We should have pressure on our y-axis. We should have 1 over volume on our x-axis, okay? If you put just volume here or up in the title, then you've really that's all that this is, right? It'd be the same thing, but it couldn't possibly be the same thing because we changed it. So you need to make sure you change your title and your labels here. Now, we do want to go through all the other steps. We want to hit series, and we want to go get a trend line on that thing. Especially now that it's linear, we're going to be putting an equation on it. So you'll hit trend line, you'll scroll down. For the label, you're going to use an equation. Okay, so this is a really nice equation here for us. This is in the format y equals mx plus b. And so it's saying that y is equal to 4, which is our slope, m, times x, which would be whatever's on your x-axis, plus 0, which is our y-intercept. So this intersects at the origin here. Okay, so moving my face cam back over here real quick so you can see we took this hyperbola right here, and then we changed it into a linear graph by graphing it using the equation for a hyperbola. Okay, so we're going to do the same thing for all the other ones that are curved. We'll go to graph 2 here. Okay, now the equation for a parabola is y equals x squared. So over here, instead of doing just the x-axis, you're going to do the x-axis squared. Okay, and since y is not changed in this equation, we'll leave y the way that it is. Okay, now again, we can just go ahead and copy position and paste it in. But for this one, since it's now the y or the x-axis squared, it's no longer just time, it's time squared, and that means our units are seconds squared. Okay? So for this one, we need to enter an equation again. Hit equals, all right? Since we don't put a 1 in this time, we're just going to click on whatever's on our x-axis, and then we're going to use that little caret thing to square it. So all I did, you can look up here at the equation that I entered, equals, I clicked on a 2, and then I hit the caret and a 2 to square it. And then when you drag that down, if you follow along up with the equations up here as I go down, you can just see that that changes from A2 to A3, A4, A5, A6, and so on and so forth. Okay, so go ahead and get some borders around this. And then what I'm going to do here is just to keep things consistent, we'll highlight that, and then I'll go ahead and make my graph here. Okay, and let's see what happens with this one. Okay, so again, that looks pretty good there. Let's make sure our title doesn't have units. So this is a position versus time squared graph. We got position in meters, time squared and seconds squared. Let's go ahead and get ourselves, let me move this here. Apologize. Okay, let me go ahead and get a trend line on that with an equation, and then we'll be done. So I can put that r squared value on there for you just so you can check it. It's a 1.0 with a linear trend line, so that's perfect. We'll use the equation. Okay, now this equation here is still y equals mx plus b, but it looks a little more busy. Our slope is 3, x is your x-axis, and then this right here, when you see this is scientific notation. This is the same thing as saying 4.06 times 10 to the negative 15. Okay, so really that number is a very, very small decimal. Okay, it's point 14 zeros and then 406. Okay, so that number is so small that we might as well just consider it 0. So if you were to, if I was asking you what is the y-intercept of this graph, it's 0. The only reason why it's not coming up exactly as 0 is because, remember, the trend line is just an average of these data points. So if they're not aligned 100% correctly, then it's not going to go through 0. And we have these tiny little, this is right above 0. Most graphs you would start with like a time of 0, position of 0. So that also factors. Okay, so we're done with this graph now. Graph 3, we don't have to do anything with this one because it's already linear, right? So we're good to go with that one. So let's look at graph 4. This will be our last one. This one is a group graph, and the equation here is y squared is equal to x. Technically, it starts as the square root of y, or y is equal to the square root of x. But if we square both sides, we can get rid of the square root. It's just easier for us to work with. Okay, so this time we are actually modifying the y-axis here based on the equation, right? So the x-axis is actually going to stay the same We're not going to change that one, but we are going to need to do the y-axis squared this time, okay? So let me get my colors on here, straighten those out. Okay, so we can leave the x-axis the same. I can just copy and paste that, okay? But I do need to square my y-axis. That has to change. So it's no longer going to be velocity. It's going to be velocity squared. And therefore, my units would actually be meters squared over seconds squared, or you could just do meters per second in parentheses squared, okay? So we have velocity squared and time, and then we'll go ahead and enter an equation here. So equals, you'll click on whatever was on your y-axis originally in that first one, and then you're going to hit the caret and a 2 to square it, just like we did on the last one. Click on that box, grab that little blue box in the bottom right corner, drag it down. It'll populate it for you there. Okay. Now we're going to highlight all of this, give it the old graph chart button. We'll edit our title, get rid of the units. We'll double check our axes, velocity squared with meters per second squared, and time in seconds. Perfect. Go ahead and move this. All right, now let's go ahead and get our trend line on there. And we'll double check the r-squared value. It's 0.999. And then we will use an equation for our label. Okay, so this has a bigger scale. So notice that our slope is much larger than the last one. So this scale is much larger. So the slope is 56.6. And our y-intercept, it says, is negative 10.5. So that means it's actually below 0 here. So if I went to vertical axis, I could say that my minimum value is negative 10. And the lights just turned off on me here. Negative 10, and put that in. And now I can actually see where it's crossing. I don't think it's a huge deal. I'm probably going to just go ahead and leave this as 0. And that would be that. Okay. So now we have finished linearizing our graphs. So part 2 of the graphing practice is finished. Our last step will be talking about mathematical expressions that explain this data. So we're going to use that y equals mx plus b equation, and we're going to draw some conclusions from it. I'm going to show you how to use that with these graphs. So that'll be part 3. Make sure you have this complete before we start that.